Hello viewers, this is Ved. Today I'm having the problem number 1.6 from SS Krotov. Okay, it is a very good problem, I can say for sure, in terms of if you talk about the kinematics as a chapter. Okay, so if you are good with the kinematics and if you want to just check yourself that how good you are at, okay, if you want to try like this way, you can, of course, if you can give a shot on this problem. Guys, to solve this problem there are very uh, two methods are there. Okay, one method is a very the basic approach, guys. Okay, the rudimentary approach, if you want to say it. Okay, if you start from very basics and solving and everything. Okay, so that is the one way of solving this problem. And of course there is another elegant way to solve this problem, that is what, the graphs, guys. Okay, so both the ways are fine, what I feel. What I'm going to do, first I'm going to start with the basic approach only, that rudimentary way. Okay, so I'm going to solve this question with that method, and then of course I'm going to solve this question with the graph also, guys. Okay, so without any further ado, let's start, guys, discussing this question. So first let me formally read for you this question, and then of course if you want to try, you can pause the video, you can try by yourself. Otherwise you can see the solution that I'm going to discuss now. Okay, so guys, the question is saying that there are two steel balls falls freely on a elastic slab, guys. Okay, elastic slab means basically that there is no energy losses are happening. The whatever the speed they will be having when they are going to hit the slab downward, with the same speed, guys, they are going to what, return it back. Okay, so let's say, guys, this is your what, elastic slab. Okay, elastic slab. Now guys, the first ball is dropped from a height of h1 is equal to what, guys, 44 centimeter. So this is what, guys, this height is given to us, 44 centimeter. And then there is another ball, guys, which is what, dropped from a another height, which is what, guys, 11 centimeter. And guys, if it has been dropped at t equal to 0, as if you see, it is saying that two steel balls, okay, two steel balls falls freely on the elastic slab. The first ball is dropped from a height h1 is equal to 44 centimeter, and the second from a height 11 centimeter t second after the first ball, guys. Okay, generally in the Krotov, guys, it is written tau. Okay, but I was not getting any word in my iPad, so I put it like t only. So okay, so guys, this is what, tau only. So the tau, the time interval. So guys, after t second, after the first ball has been dropped, the second ball has been dropped, guys. Okay, so this is, let's say, first ball, guys. Okay, this is the first ball. So guys, this is your what, second ball, and it has been dropped at t equal to what, guys, capital T or tau. Okay, whatever you want to write. Now they are saying that after the passage of time t, after the passage of time t, guys, means at t equal to 2t. Okay, at t equal to 2t, the velocities of balls coincide in the magnitude and direction, guys. Okay, so the magnitude is also same and direction is also same. Okay, so guys, this is given to us that both will be having, guys, what, same velocity. Okay, now in the last, guys, it is asking the question now, determine the time t and the time interval during which the velocities of the two balls will be equal, assuming that the balls do not collide. So of course, guys, I have separately drawn the pathways of both the bodies, so there is no collision is going to take place. Okay, so let's start discussing, guys, this question. Okay, so what I'm going to do, guys, if I say that, let's say, if this height is what, h, so this height can be simply, guys, written as what, 4h. Okay, I'm going to do everything, guys, first in the parameters. Okay, in the variables, and then maybe if we need the data, we will feed the data in the answer. Okay, so guys, let's see. So guys, if this is 4h and this is what, h, so if I see, guys, the thing is, one thing that we can say for sure, if it is going down, if it is going down, guys, started from t, and it is guys, coming already. Okay, so of course during this part of the journey when they are going down, that is there is no chance that they will have what same speed, that's for sure. Okay, they will have the same speed, that is not possible. Only when it is possible guys, when let's say if tau is what this t is what guys 0, means when they both have started from the same time, then they will have what the same speed and same direction, that is possible. Okay, but if we are taking some other possibility, means when the t is what non-zero, then guys this is not possible that when they are moving downward they will be having same velocity and direction at some particular moment, that is not possible. It means one thing that I can assure you, that the when they are going to return, when they are going to return like this, okay, then only there is a possibility that they will be having what same speed and the direction. Okay, same speed and the direction, that is the only one possibility that is possible guys. Okay, so with this thought, what I'm going to do guys, I'm going to start the problem. So if you see guys, let's calculate this time. Okay, when the bodies are going to what guys fall. Okay, so this time guys I want to calculate this time. Okay, so if you see in the first one guys, uh, if you talk about, we know that guys s is equal to, which is what 4h is equal to what guys, u is 0, initial velocity is 0, so it will be what guys half g t square. Okay, so I'm doing a little short guys, so just see it properly. So it will come guys what 2 under root 2h by g. Okay, that is what guys t, that is the t that we have gotten guys. Okay, and if you see guys for the particle 2, it will be what, this is what guys for particle 1, particle 1 for particle 2 guys. Okay, for particle 2, if you talk about for particle 2 guys, if you see this is going to be 2h, sorry guys, it is going to be h is equal to half at square, and this is t dash, let's say guys, and that will be what under root of what 2h by g. Okay, so guys if you see from here, I'm going to call this t dash as a what guys t naught. Okay, I'm going to call this t dash is equal to what guys t naught. So t will be equal to what guys 2 t naught. Okay, t will be what guys 2 t naught. So this you have to keep in mind. Now the second thing is guys about the velocity. Okay, so if you see guys, when it is going to hit the ground, when it is going to guys what hit the ground, it is going to have some speed. Okay, that speed would be how much guys, if you see, that is if you remember, so you can directly say, but okay, I'm going to solve for you guys this also. So if you see final velocity v square is equal to what guys, initial velocity is 0 plus 2g into what guys 2h. So v is equal to what guys, sorry, this is 4h, 4h. So guys it is going to be 2 under root of 2gh. Okay, and for this guys, if I take this as v dash square, so this will be 0 plus 2gh. So v dash is equal to what guys, under root 2gh. Okay, so so if guys I call v dash is equal to what v naught, then 2v, sorry, v will be what guys, it will be 2v naught. Okay, so these datas guys we have to keep in our mind. Okay, for the calculation. I hope this is okay, I hope guys this is okay. Now I'm going to give you the final solution guys of the discussion. So if you see, uh, let's discuss this guys further. Okay, just let me take some other color. Okay, okay, so guys now if you see, suppose this time guys where they have taken, and when they are having the same speed, let's say this is what guys t1 and t2. So what I can call guys, I can call that this time. Okay, this time, because guys see, this is happening, this thing which is going to happen is going to happen guys after what t second. So what we can say guys, for the particle 1, for the particle 1, for the particle 1, particle 1, event is going to happen, event is going to happen going to happen at 2t seconds, guys. Okay, because guys, if you see, it is saying in the question that t second after the first ball it has sorry guys, like second ball has been dropped t second after the first ball, so t second has been gone there already. Okay, and then after the passage of time t, okay guys, the velocities of the balls coincide. It means it has taken how much time total, 2t, when they are going to have what, same velocity. So guys, it has traveled, total motion is how much guys, 2t seconds, and the first one has traveled how much guys, of course t seconds. Okay, then only the event is going to take place. Okay, so for the second ball it is t seconds at from the start, t equal to 0, when the movement is going to take place, and for the first ball guys it is what, 2t seconds. Okay, so if you see what we can say guys now, if you see guys, for the first particle, guys, we can say 2 t naught, okay, 2 t naught plus t1 is equal to what guys, 2t. Okay, if you want to write t or tau, whatever you want to write, you can write that. And guys, for second ball, okay, or for second particle, and for second particle, when the event is going to take place, of course, for the second particle, when the event is going to take place, event is going to take place, it is taking how much time guys, it is taking t naught plus t2 is equal to what, tau, when it is going to happen. Okay, so it is happening from its start of the motion after tau second. Okay, when they both are having guys what, same velocity. Sorry guys, I'll make it t only. Okay, so t naught plus t2 is equal to what guys, t, and 2t naught plus t1 is equal to what guys, 2t. Okay, now if let me add one more page guys. Okay, so if you see guys, now uh, guys, let's put the values of t1 and t2, then it would be very easy guys. So if you see so 2t naught, t1 will be how much guys, the velocity is going to be same. Okay, so for this if you see, I'll put here only guys, velocity is going to be same, so v is equal to, initial velocity will be what guys, it will be you can say 2v naught, okay, minus, okay, because it is in upward direction, and g into what guys, t1. Okay, so it will be, if you see guys, it will be uh, v minus 2v naught divided by minus g. Okay, so we can write this as t1 is equal to 2v naught minus v divided by g. Okay, so guys, let me put this value here. So 2v naught minus v divided by g, okay, is equal to 2t. And for the second particle guys, we can say, for the second particle, guys, it will be what, simply we can say it will be v is equal to what, v naught minus g into t2 guys. So it will be what, it will be v naught minus v divided by g, that is what guys, t2. Okay, so let's put that value also guys. Okay, so if we put that value also, so t naught plus v naught minus v divided by g is equal to what guys, is equal to t. Okay, now what we will do guys, we will subtract these two equations. Okay, 1 and 2 I am going to subtract. So guys, if we subtract, we will get t naught plus 2v naught minus v divided by g minus v naught by g plus v by g is equal to, t. If you want to do guys like this way, I have solved it. So if you see t naught, you can check the calculation also. So guys, it will become what, it will become uh, v naught by g, and guys the rest will be what, cancelled, and that is equal to what, t. So guys, now you know the t naught value and you know the v naught value guys, we can put the values of both. So guys, this will be what, under root of 2h by g, and this will be what guys, under root of 2gh divided by g, and that is equal to what guys, t. So t will come how much guys, it will come 2 of under root of 2h by g. Okay guys, so it means that this event which they have talked about is going to happen for the first time at t is equal to what, guys? 2 under root 2h by g. Okay, after the second particle has fallen. Okay, so guys, now I hope till this you are with me. Okay, you have understood this part of the question. So if you want to find out the value, guys, you can put the value of h, you can put the value of g, you can get the answer. But that is not my interest. Okay, my interest is, guys, now what? Finding the interval. Okay, finding the interval after which this event is going to be repeated again and again. Okay, the event is going to be what, guys? Repeated again and again. So that is the second part of the question, guys. Okay, so part 2 of the question, part 2 of the question, guys. Okay, what? Finding the interval, finding the interval after which, after which the event is going to happen again and again, again and again. So guys, of course I'm going to solve this part. Okay, but of course the graph part will take, guys, a little bit more time, so I'll cover that part of the solution in the one more video. Okay, so this basic method, guys, I'm discussing in this part of the video. The second part of the video we'll be discussing the what, the graph method, which also the Krotov have discussed in his solution. Okay, so that is another part, but I wanted to give you something unique also, which is not in the textbooks in general. Okay, so we are doing with the basic way also, that how do we approach this particular problem. Okay, now if you see, guys, part 2 of the question. So if you see, let me make the figure first so that I can show you something. So if you see, guys, that let's say this is your object 1, guys. Okay, so we know that it will take, guys, what, this time 2t naught here, which is equal to what, guys? T only. Okay, and there is a particle, guys, here, which will particle 2, and guys it will take how much time to come down, guys? T by 2. Okay, so if you see, guys, if this is t equal to 0, and this is what, guys? T equal to tau we have dropped. So guys, it will t equal to t, guys, it has been dropped. So guys, at the time it has been dropped, it has already hit the ground floor. Okay, it has already hit the what, guys? Ground floor. Now in the next t second, guys, it is going to what, reach to this point, and this is, guys, in the t half second going to reach what, the topmost point. And that movement, guys, they will be having what, same velocity. Is this okay? So if you see, that is the first thing that we have derived. Okay, so if you see, guys, here, if I show you that this time is also going to be what, guys? T by 2, and this time is going to be what, guys? T only. So if you see, guys, at the t equal to what, t equal to 2 tau, if you see, okay, we have seen that 2 tau or 2t, guys, they are having what, same velocity. Now from here, guys, the new part of the journey is going to begin. So now if you see, guys, what is going to happen? What they have asked, guys, in the question, they had asked that determine the time t and the time interval during which the velocities of the two balls will be equal. Okay, like after which time intervals, guys, this is going to be equal. Okay, and the time interval during which the velocities of two balls will be equal, assuming that the balls do not collide. Okay, I think they are asking this only, guys. Okay, so if you see, now, guys, they are going to repeat their motion. Okay, so if you see, guys, now what is going to happen? Okay, guys, it is going to begin from the same time, guys. Okay, they are going to begin the motion from the same time at t equal to 2t, guys. Okay, at t equal to 2t, they are going to begin the motion. Okay, so that time, guys, they are going to have the same velocity. Now it will take, guys, what, it will take 2t further time, guys. Okay, 2t further time, and in that, guys, it will it will be, guys, what, it will be somewhere uh, guys, go like this, okay, and come like this and go like this, guys, okay. It will be here. If you see, guys, this part of the journey is what, t by 2, t by 2, t by 2 and t by 2. Can you see or not? So guys, of course, in the time 2t, it will be what, guys? It will be 1 minute, guys. I think I have done some mistake. Just a minute, guys. This will be what? This will be t only, no? This will be t, guys. Okay, so just let me correct this part. This will be, guys. Okay, okay. Now, yes. So, guys, it will take time t to go down, and in this, guys, it will go to what? Topmost point. So, guys, now it is going to go up. It is going to go up, and when it is going to go up, guys, it is going to come down, okay. So when it will reach, guys, up to the top in the t time, it will again, guys, what, reach to the top in the same t time. Is this okay or not? Okay, so again they will be having what, guys, same velocity. Can you see? So it means the, guys, after, again when they are repeating, guys, their motion after 2t time, they are repeating the motion, okay. So it means the time interval, the time interval time interval after which the motion is getting repeated, the motion is getting repeated, is simply 2t time interval. It is repeating its motion, guys, okay. After 2t time interval, it is having the, guys, what, same velocity. Both will be having, guys, what, same velocity in the same direction, okay. So both are, guys, having what, same velocity and the same direction after 2t interval, okay. So this is going to, guys, begin and begin. So we can say that t is equal to what, guys, 2 under root 2h by g, and delta t, after which, guys, it is going to be performed again and again. That will be what, guys, 4 under root of what, 2h by g, okay. So that would be what, guys, answer of what, the time interval after which it is going to be repeated again and again, okay. So I hope, guys, this method has been settled down for you, okay, the basic method. If you have any doubt in this methodology, guys, you can discuss in the comment section, guys. You can share. I would love to share the explanation on that thing. And of course, guys, in the next part of the video, we are going to discuss the graph method, and I'm going to show you that is a much more elegant method to solve this problem, okay. Of course, this is what more you can visualize, okay. You can see that how the things are happening, but there, guys, you can see that with the pure math only, using the geometrical properties and everything, you can solve this question in a much easier way, okay, guys. So thank you for today. I'll see you in the next part of the video of this question, okay.